Okay, so just to introduce myself, I manage what's called the Qatar Carbonates and Carbon Storage Research Centre, which is one of Imperial's largest industry-funded research centres. But we particularly look at just the storage of CO2 in the reservoirs. Obviously, in Qatar, which is basically a carbonate reservoir-dominated country. But today I'm going to have a high-level presentation about CCS in general, about where the barriers are right now, because I was asked to sort of step in and talk about CCS. So we have another umbrella sort of network within Imperial called IC4S, where basically all the CCS people can sort of chat and swap ideas and put in bids together. If I can get the, here we go. So, in case you don't know what carbon capture and storage is, I hope everyone does, but it's not been in the press hugely compared to other technologies. Effectively, the idea is to capture the CO2, as is shown by one of the DNV's diagrams here, and lock it away permanently. And we can do that through injection deep underground, either into deep saline aquifers, so that's just this porous rock that has about 20–30% porosity and has a lot of potential for pumping the CO2 into it, or depleted oil and gas reservoirs, and there's also the possibility of coal bed methane, etc., but we'll skip over those ones. The key thing about CCS is it's not one technology, it's many, many different technologies, and it's applicable to many, many different industries. And so we've got listed here: power, heating, industrial processes from cement, iron, fertilizer, etc. So it's quite a broad grouping of technologies. So just to ram home the point again, we need to be acting quickly because at the moment we have a problem of global climate change running away from us, and really 6-degree scenario, we're bang on schedule for that because we're not doing enough right now. Various scenarios throughout the planning, and basically it boils down to some of the cheapest ways to decarbonize to a 2-degree scenario and get low is through utilizing CCS in one way, shape or form or another, plus lots of other technologies, energy efficiency, shifting fuels, etc. But the key take-home point is CCS is still required because it's actually going to be cheaper in the long run. And one of the points here is BECCS. So I'll come on to briefly talk about BECCS, which is slightly different from traditional, what we call CCS. So from the Grantham little handout we had earlier, you can see that that's the technology readiness level for CCS, though talking particularly just within the industrial sector here for steel, I believe, was actually 4 to 6. So it's almost getting towards deployment. And I'll hopefully change your view about how that can be much more rapidly deployed in the next few slides. And again, the negative emissions I've already mentioned about BECCS, and direct air capture. There are commercial people doing this throughout the world, but it's still quite expensive comparative. But anything to do with hydrogen as well, there's several of these other graphs that have the hydrogen in there, you're going to be needing CCS. We can't just depend upon hydrolysis of water. Maybe seawater is more usable than water, but certainly steam methane reformation, as is already done in the world. We already have a CCS plant built on with this SMR in Canada, and it's operating very, very well up in the Quest project in Canada. But we also have traditional power. Coal and gas can be decarbonized or heavily decarbonized with CCS, as in the SAS Power Boundary Dam plant in Canada has one of its units now working with CCS. So the technology readiness levels of 4 to 6 is a fair point when you look at particular areas, but then when you actually look at the bigger picture, as I said, CCS has many, many different technologies within it. And these are sort of all grouped here, and there are various technology readiness levels. You can see CCS is already basically deployed around the world, so we're doing it. CCS in certain industries is not, or is either in pilot phase or is being deployed currently. And we have lots of people at Imperial working on various aspects of these. Although an academic may be quite narrow in the field of view of where they're looking at, for example, membranes for capture, or chemical looping, or calcium looping, or ionic liquids that we have people working here on heavily. the way that we nicely work here is we can work together well and get this multidisciplinary. And in the project I run, I would say it's more about transdisciplinary. It's really getting, because it's over 10 years of project, we get PhDs who then can transfer into postdocs nicely. And not only are they key experts in their experimental domain, they also have some really very good skills, if not also experts in their modeling domain as well, for their particular part of the CCS chain. So what I'm saying here is basically CCS is ready to go and is going. But then what's the real problem? Why isn't it actually going globally and quickly? Because we need it. So CCS, rather than seeing this as a sort of excuse to continue the burning of fossil fuels, it's much more a case of CCS as a real partner for renewables in the long run, allowing a full transition basically to renewables, bar those industries that have to have CCS attached to them. They can't be powered by renewables or produce CO2 in the process like cement. So this graph basically just showing you the electrical system optimization model in the UK, and this is just focusing for the UK, about how throughout for 2050 and how we need to meet our climate change goals through the legislations we have, and how that can be best done through various different technologies. Get this thing right. But you got to think about the bigger picture. It's not just the UK we have to think of, it's the globally and also the Sustainable Development Goals that the UN has. It's really quite a key thing. We need to not only do things cheapest, but we actually need to make sure that energy can get out there to everyone and make sure that we're not actually taking away resources from something else. We could spend lots of money doing one type of decarbonisation, but actually that will stop potential money going into other things about human health or education, etc. So we have to see things in a bigger picture and balance the politics of it all effectively. So how do we achieve a massive cut in gigatons of carbons released as we are doing now by 2050? And if you just want to have a quick answer to that, it's basically energy efficiency. We can work a lot of that. And then also basically looking at the basically zero emitting CO2 energy sources, renewables and nuclear, but also we need to look at moving on to gas with CCS more so. And even coal with CCS, where countries where it's just inbuilt and it's necessary, particularly from a social aspect, because they're so dependent on coal to keep that going, but with CCS. And how are we doing so far? Well, to get that 2050 mark, this is some work published in the MIT Tech Review. Basically, we have to be deploying a certain amount of clean energy per year. And basically, they've estimated that it should be about 1,000 megawatts per day, and we're doing about 150. So right now, we're not deploying enough clean tech, low carbon energy to supply the world's needs for us to meet our 2-degree scenario. So it's quite sad, but that's the way it is. So we need to speed things up, and we actually need to start using all of our techniques that we have possible, and we need to be doing it fast. CCS is going on around the world. We have some various plot here showing you the years that the plant started and the type of industries they are. It shows you the diversity of CCS. And the key thing here to take home is that the old graphs used to have lots more of these bubbles all the way over into the future. And right now, we don't really have any in the future because there's nothing really in the pipeline for CCS projects. That's not a failure in industry. We've got the technology, we can do it. It's a failure on the policymakers from actually getting the right policies in place to make CCS going to be happening. So, CCS started in the 70s and we need a massive rollout by 2050. We need about 2,000 plants at the 5 megaton per annum. So most of the plants we have now are about 1 megaton per annum. But there is hope. I don't know if you've heard about net power in the US, but this is a new sort of way of producing power using CO2 as a working fluid. Instead, producing lots of clean 100% CO2 for us to then go and also store. So this plant is currently being built. It was meant to start up, but it hasn't quite yet. And it's commissioning problems as always in these types of projects. So hopefully if this gets up and going, that's a power production that'll be really nice and clean. But then I'll also cascade into numerous other small spin-offs that are going to be available there for industry to use oxy-combustion and really cut cost of doing CCS with power by at least about 50% if the Allen cycle and everyone else all works nicely, which he was here a couple of weeks ago and he assured us it was. So BECCS is the bioenergy CCS problem. So this has some other issues with it regarding competition for space, competition for water, particularly as will hydrolysis of water for hydrogen. But basically the idea is you grow the plants, the natural material, and then you basically chop it down, burn it, and that CO2 produced from those plants, you capture, you store it underground. You let nature do the hard work, which is capturing the CO2 for us. She's good at that, nature. And then we can store the CO2 deep underground. We're actually quite good at that. We've done it on numerous plants around the world, and our subsurface engineering is fairly sound. Where we are basically with BECCS is that we're right here at 0, and for these predictions for meeting 2 degrees, we need to have a massive installation of BECCS around the world, which is, some people are saying, not really realistic. So if we're not going to make the BECCS, we need to start thinking of other things as well that we can catch up the CO2 deficit from. Otherwise, we need to start doing BECCS quickly and efficiently. And that's the coal projection there, which is actually starting now to almost happen. We're at the sort of peak of coal. Maybe not the peak, but certainly plateaued at least. Oil and gas is still ramping up, and solar obviously is ramping up, but the graphs are, solar's down here, and oil and gas are still up here, and coal plateauing. So we've still got problems, and we're not addressing them fast enough. Utilization is wonderful, and if we can utilize the CO2, we should. However, we shouldn't mistake this necessarily for a climate mitigation tool. CO2 EOR has obvious issues to do with releasing of more hydrocarbons, but also a lot of the technology, a lot of the end products have a very short lifespan. Therefore, you're actually releasing the CO2 in days, weeks, months, years. Very few of them lock them up. About less than a quarter will lock the CO2 up permanently. So it's not actually solving the CO2 in the atmosphere problem. What it's really helpful is actually tackling the cost of CO2 capture technologies and bringing those costs down by making them more widely available, which is excellent. So how do we make CCS a commercial reality? Effectively, there are no technical barriers right now. We can deploy a plant on numerous different industries if you give us the right place to put the CO2 and the permissions to do all the pipelines, etc., and get the CO2 from the plant. What we do need is some kind of monetization, and that is either in the US recently, you might have heard of the Q45 tax incentive that President Trump brought in, which was, from the CCS point of view, is actually beneficial. We're going to now have a lot more CCS projects in America kick off because they're getting paid to store CO2 either in a saline aquifer or to use it for CO2 EOR. So this is a really good thing from the CCS point of view. Norway already taxes CO2, and they're basically the countries that are really heavily looking at, already have CCS plants operating, and will have some more in the future. The EU is probably, from CCS point of view, CCS is the most heavily regulated, non-existent industry that we have, because we have no CCS in the EU, but we have some heavy regulations on it, lots of talking about it, and lots of pushing around paper, but there's no action. It's quite depressing. So there's lots of slides. If you see the slide pack, there's slides going through all these things. I'm just going to read them out quickly. We've got to target other things apart from power. Power seemed to have a UK CCS fascination with it. Before I came to Imperial, I was working in the Middle East on a gas processing plant, and they were storing plenty of CO2 as acid gas quite happily, and not even batting an eyelid. We've taken a long time to look at industry in the UK, and particularly the Teesside Collective, etc. And now we've got the Acorn project, and actually the 3 in the UK, Acorn, Teesside, and Caledonian Energy. None of them are particularly power. It's all sort of industry related. Multi-scale plants, multi-plant, large-scale developments. That's where our process sort of systems engineering point of view comes away. That's where we're very strong here at Imperial. Looking at the big picture, how does the hydrogen for planes, for cars, link into the renewables production, and how can gas CCS or coal CCS supplement renewables? Looking at that massive entire process systems there. And key things is really, we've got to get from the first of a plant to the nth of a kind. Because first of a plant now, in the Canadian examples I gave you in Quest and SAS Power, basically they're saying the second generation there'll be a 30% cost reduction. So if we keep on rolling them out, we'll get a much larger cost reduction. And yeah, supportive policy framework. Well, hopefully Chris Perry recently made some comments about working with Faith Bryro in the IEA and taking CCS really seriously from the UK point of view is excellent. The Scottish Government is also very keen on CCS, and some of their presentations recently have been very strong CCS. But yeah, we need some new business models for risk sharing, and yeah, there's a lot more background information and new reports, etc., attached to these slides if you're interested in CCS. So I'll leave it there.